Hello, everybody. So in this video, we're going to solve one example to get more used to the process of or the drawing the flow sheets and using the information the flow sheet um, to solve the problems or the mass balance problems and calculate the missing information. So in this example, we have an experiment where we have uh, a process where we want to grow um, certain microorganisms, and we require to provide humidity and oxygen. And this is done in a special chamber where we have three input streams that are fit into the chamber to produce one output stream. We have information about the three input streams. The first is liquid water. We know its volumetric flow rate. The second is air, which is 21% oxygen and 79% nitrogen. And the third stream is pure oxygen with molar flow rate of 1/5 the molar flow rate of stream B. Then we know the output gas contains 1.5 mole percent water. And we want to draw the process and calculate the unknown variables. So this process consists of a humidification chamber. It doesn't matter what it looks like or what happens inside. Or all what we care about now is putting a block. Then we say that this is the humidification chamber, and we have these three streams going in and one stream going out. So when we do this, this is the flow sheet with all the information that we have, the volumetric flow rate, and I put the numbers for each stream. So 1, 2, 3, and 4. We know the mole fractions. We know this mole fraction. So these are all the information that we have. The first thing that we did is draw the flow sheet, put the information. We put even the symbols for the missing parameters. So I don't know the mole fractions for oxygen, nitrogen in the output stream. I don't know the number of or the molar flow rate for all the streams. So what we can do now is we can proceed with the solution. The first thing we said that we have to unify the units. So the unit that we have here is volumetric flow rate. It's not going to be possible to use it with the mole fraction. So we have to calculate the molar flow rate from the volumetric flow rate. We know the relation between the volumetric flow rate and molar flow rate is something we covered in chapter 3. And we know that we cannot go directly from the molar volumetric flow rate to the molar flow rate. So we have to go through the mass flow rate. So if we multiply this volumetric flow rate by the volume, the density, then we have the mass flow rate. So these two together represent the mass flow rate. And if I divide it by the molecular weight of water, we can get the molar flow rate. So now I have N1 as 1.11 gram moles per minute. Now we have to use equations to calculate the missing variables. The equations that we have are going to be mass balance equations. We said before that the mass balance equation is possible to be used with one component, with more than one component. It can be used with for masses and for moles. So we can apply the mass balance equation here. In this case, we have steady state problem, so there is no accumulation. In this case, we have no reaction takes place between the components in the chamber. It's just humidification. It increases the water mole fraction in the air. And in this chamber, this chamber there is no reaction, so there is no generation, no consumption, and no accumulation. So the mass balance equation will be simply in equals out. So what's going in equals what's going out. We can apply this equation on components and on the total. So let's apply this equation on water. So we have water here and there is no water here, and this is one thing that is very useful when you draw the flow chart and put all the information on the flow chart, that you know which stream contains which component. So I know that this stream contains oxygen and nitrogen only, this contains oxygen only, this contains the three components. So I know that the water is only present here and here. So from mass balance, we can say that the water here, which is the N1 W water 1, which is N1, equals the mole fraction of water in stream 4 multiplied by N4. And from this, we can calculate N4, which is almost 74 gram moles per minute. So now we calculated the molar flow rate here. Now, to continue the solution, we have some options that we can use. The options are using the mass balance on oxygen, on nitrogen, or the total mass balance. So we will try them all and then see what is the or how can we proceed. Um, Part of this or the goals of this problem is to show that there might be different routes and we need to uh, know that. And in the coming videos, we will see how to know beforehand how you are going to start and what are the equations that you can use, or they're going to be easier to use than others. So this is something we will do in the future. But for now, let's write the equations and see which one we can use. So if we write the equation for nitrogen, we will have nitrogen only here and here. So we'll say that 0.79 times N2 equals Y nitrogen times N4. By substitution, we'll see that we have two unknown variables here, so it's one equation into unknowns, so we cannot solve it. If you do the same for oxygen, we'll have oxygen here, here, and here. And of course, this is from the definition of the mole fraction, Y equals N over N total. So if I want to calculate N, so it's Y times N total. So this is what we are doing. And by substitution, you would see that we have still two variables. And here I also included this relation that N3 equals 0.2 N2. So this reduced the number of variables to 2 instead of 3. So we can solve these two equations together, but there is another easier way to do this, which is using the total mass balance. Here you will have the fractions or the numbers that will make the calculations a little difficult. So here, if you use this equation, you can directly calculate N2, and from N2 you can either substitute here or here to calculate Y of nitrogen, and of course Y of oxygen can be calculated accordingly, as you see here. So this is simply how we can solve this problem. Again, in the coming videos, we will try to make this problem more systematic. We will know what are the information that we need to know, and if the information that we have is enough or enough, or we need to have more information. So this is the flow sheet after putting all the information in. I'll stop here and we'll continue next time. See you then.